Okay, this video is for Algebra 3 Notes, section P.3, Radicals and Rational Exponents. We're only going to focus on radicals for this section. We're on Unit 2, Quadratic Equations. So when we're simplifying square roots, you're reducing a radical to its simplest form. And there are two different methods that you may have learned, and I'll explain both of them here. So the first thing you look for anytime you're reducing a radical is it a perfect square? So this example right here, the square root of 49, that's a perfect square, meaning 7 squared is 49. So this just reduces to 7 because this is a perfect square. And I would expect every one of you to be able to find perfect squares. You should know your perfect squares up through 15. Then this number here, 56. 56 is not a perfect square. 7 squared is 49. 8 squared is 64. So I know it's somewhere between 7 and 8. So the two different ways that you could be shown this is you could make a chart where I take 56 and I'm going to break it down into its factors. So I know 56 is divisible by 2. 56 divided by 2 is 28. I know 28 is divisible by 2. 2 times 14 is 28. 14 is divisible by 2. 2 times 7 is 14. And 7 is a prime number, but I'm going to go ahead and put the 7 here. My goal is to get a 1 in this column. So now that I have all the factors, I take up the group. So here I have a group, I have a pair, I should say a pair of 2's. So this goes together. Any pairs go on the outside. And the inside, what I have left, I multiply together. So 2 multiplied by 7 is 14. So this is going to give me 2 square roots of 14. If you're comfortable with that method, you can use that method. You don't have to. The other method is going ahead and finding the perfect squares. So the way I think of this is I'm going to say 10 squared is 100. 9 squared is 81. And I'm just going to list them all down here. And 2 squared, oops, I forgot, 3 squared, and 2 squared is equal to 4. 5, 6, 7, 8. I'm just double checking them. And you could go on higher if you want to. So I could say 11 squared is 121. Typically this will cover it all. So then I take 56 and I start looking at what divides into 56 evenly. And you could use a calculator, but the faster you know your multiplication, the better for you. I can't divide 56 by 121 or 100 or 81 or 64. They're all too large. My goal is to get an integer, a whole number. So 56 divided by 49 is going to give me a fraction. 36 doesn't work also, and I can get a calculator and show you what I mean. If I take 56 and divide it by 49, I get a decimal. 56 divided by 36, decimal. 56 divided by 25, decimal. 56 divided by 16, 56 divided by 9, 56 divided by 4. So there I've got it. I've got my integer. So that means 56, if I take the square root of 56, it's going to break up into 4 times 14. The square root of 4 is my perfect square. So I get 2 square root of 14. Whichever method you learned in Algebra 2 or whichever method you're more comfortable with, it doesn't matter to me. I just want you to be able to reduce radicals. So here's one that has a variable in it. So the square root of 16 and the square root of x squared, I can look at these separately if I wanted to. The square root of 16 is a perfect square. This is 4. The square root of x squared is going to be x. I can, if you think of it as its multiples, x multiplied by x. There's 2 of them, so I bring out 1. In Advanced Algebra 2 and Algebra 3, a lot of times we start talking about absolute value bars. And what happens here is if you were to take a negative number, say -3, and square it, it becomes positive. So if I wanted to replace this x again with -3, I'm not going to have a negative number, because if I take the square root of something that's been squared, it's always going to be positive. So in Algebra 3, we talk about the absolute value of x. I'm not going to be real strict on that. It's just something I want to make sure that you see, but I'm not going to test you on that here. So then I've got the next one is square root of 24, square root of x to the fifth, and square root of y. 24 is going to be square root of 4. Let me reset clearer. Square root of 4 times the square root of 6. X to the fifth is going to be x 5 times. So I have a pair of x's here and a pair of x's here. And then y doesn't break down at all. So I'm going to have the square root of 4. I'm going to have a 2 on the outside. I have 2 groups of x's, so that's going to give me an x squared. The 6 is going to stay inside. There's going to still be an x inside, and there's going to be a y inside. And I do not need absolute value bars on the outside with this x squared, because no matter what value you put for x, it's going to be a positive because you're going to square it. And we never put absolute value bars on the inside. Okay, also with radicals, we're going to multiply. And the process is not complicated. You just have to make sure you simplify well afterwards. So if I'm multiplying radicals, anything on the outside gets multiplied together. So there's a 1 there and a 1 there. I multiply them together, I get 1. Boring. Square root of 5 multiplied by the square root of 3 is going to be the square root of 15. And then I look to see if that breaks down. It doesn't. So that's going to be my answer. And then I would check it with a calculator. I love checking my answers with a calculator. So what I would do is I would take the square root of 5 times the square root of 3, and I get that decimal, 3.87, and then I take the square root of 15, and I get the same decimal. So I'm confident that's correct. Same thing here. It's going to be outside multiplied by outside. There's not a number in front of the 14, so I know there's going to be a 1. 1 multiplied by 3 is 3. 14 multiplied by 7 is 98. That's multiplied correctly. Now I'm going to go ahead and reduce it if at all possible. So I can take the 98, and I know 98 is going to be 49 multiplied by 2. And that's just the way I choose to do it. So the square root of 49 is 7. Now I'm going to multiply this 7 and the 3 together, so I get 21 square root of 2. Okay, then I'm going to go to a more complicated one, but it's still the same process. I multiply outsides together, so 2x multiplied by 6 is going to be 12x. 5x multiplied by 10x is 50x squared. So I'm going to break up this 50 is going to be 25 times 2, the square root of x squared. I'm going to write. So now I can break everything up. Square root of 25 is 5. Square root of 2 stays where it is. And the square root of x squared is absolute value of x. Now I'm going to multiply all the terms together on the outside. So 12 multiplied by 5 is 60. X multiply absolute value of x. It doesn't matter that this is absolute value. It's just going to be x multiplied by x, so I get x squared. And I don't need my absolute value bars anymore, because no matter what value x is, it's going to be positive. And I have the square root of 2. And I could check with this with a calculator. I've shown you before. So I would go ahead and I would see what my value of x is. So I'm going to hit x, enter, and my x is negative 54. That's fine. It doesn't matter as long as it's not 0 or 1 or negative 1. So I'm going to type in exactly what I started with. 2x square root of 5x times 6 square root of 10x. And I'm just going to, oh, non-real answer. Can't use 59. Okay, so let's use, 13 is my favorite number. Let's store 13. I should have known that before I looked at it. And then I'm going to do the same thing again. 2x square root of 5x times 6 square root of 10x. And I get this huge number, 14,340.125. I don't care about that number, but then I'm going to come down here and check my answer. So 60x squared and then square root of 2. And I have the same number, so I'm confident that's the correct answer. The next page, and there are 3 pages to these notes. The next page is talking about dividing radicals. So in dividing radicals, you're just trying to reduce the fractions to simplest form, and you may have to use a technique called rationalizing the denominator. So the first one I look at, the square root of 25 over 9, I want you to recognize those are both perfect squares. So the square root of 25 divided by the square root of 9 is going to be equal to 5/3. There's nothing difficult about that. Notice this was written as 1 square root. This next one has 2. But what happened in this first example is I took this 1 square root and I broke it apart. And it works. So this one has got 2, and I look at it and think first, let's see if I can reduce before I do anything else. So I have 20x to the 4th over 5x. Well, I can reduce 20 over 5 is going to equal 4. X to the 4th over x is going to be x cubed, and I want the square root of that. So what happens, the square root of 4 is 2. X cubed is 3 x's. So I need a pair of x's, they go on the outside. And I have 1 left over, so that stays on the inside. And then just to take care of any of the negatives, if this value of x were negative, I don't want the negative value, I want the positive. So I put absolute value. Now this next one is where it gets different. Usually this is shown to you in Algebra 1, although a lot of students don't remember it. I have a radical in the denominator, and I'm going to rationalize the denominator because it's just not proper to have a radical in the denominator. Nothing wrong with it. It's a technique we'd like to show you. When you get higher level in math, it's a technique that we use for different things, not necessarily something as simple as this. So what happens is I have to multiply by the radical. So I'm going to multiply by the square root of 7 in the denominator. And if I multiply that in the denominator, I have to multiply that in the numerator. So now I multiply straight across 3 and the square root of 7. I cannot multiply them together and make anything different because one's on the outside, one's on the inside. But when I multiply the square root of 7 and the square root of 7, I get the square root of 49. Well, that's a perfect square. Makes sense because the square root of 7 squared is equal to 7. So this reduces to 3 square root of 7 over 7. And that's it. It just changes its appearance. You might also see it in the form like this. So this had 3 and then just the square root of 7. This has the square root of 5 over the square root of 3. So just like the first two examples, I could write this as the square root of 5 over the square root of 3. I'm going to rationalize this by multiplying by the square root of 3. Whatever I do to the top, I have to do to the bottom. The square root of 5 multiplied by the square root of 3 is going to be the square root of 15. And the square root of 3 times the square root of 3 is going to be the square root of 9. And the square root of 9 is 3. So that's where it stops. And then a more complicated one. This is, as you go higher in math, you see more terms like this. What's going to happen is I can't just multiply by the square root of 3. When I multiply by the square root of 7 here, I got rid of the radical in the denominator. When I multiply by the square root of 3 here, I got rid of the radical in the denominator. To get rid of the radical in the denominator, I have to multiply by the conjugate. So the conjugate of a plus the square root of b is a minus the square root of b. So since I have 2 over 5 plus the square root of 3, I'm going to multiply it by the conjugate of 5 minus the square root of 3. What this is going to do, and you'll see in a minute, I'm just going to get rid of the square root of 3 in the denominator. I'm just manipulating it. So I'm going to multiply 2 multiplied by 5 gives me 10, minus 2 multiplied by the square root of 3 gives me 2 square roots of 3. When I look at my denominator, 5 multiplied by 5 is 25. 5 multiplied by negative square roots of 3 is negative 5 square roots of 3. Square root of 3 multiplied by 5 is going to be plus 5 square roots of 3. And positive square root of 3 times a negative square root of 3 is going to be negative square root of 9, which is 3. And then what will happen, get a different color, this term and this term are always going to be 0. So this gives me 10 minus 2 squared is 3. 25 minus 3 is 22. You can factor a 2 out of the numerator. So 2, 5 minus the square root of 3 over 22. This 2 and this 22 will reduce. So you get 5 minus the square root of 3 over 11. Sometimes, and there's nothing wrong with this answer, but sometimes if you're checking your answers in the back of the book or checking them on any of the sites online, the answer can be written like this, and that's okay. They're fine. This is less work, so I usually stick with that. And then the last page on these notes is we use a lot of terminology in math, and sometimes I forget to tell you about it. So this diagram shows you, if I'm talking about the index, I'm talking about the power that's out here on the square, like the square root symbol. So this is a radical. The number or term underneath a radical is called a radicand. The whole thing is called a radical, and that number is the index. So what happens when you're adding and subtracting, same as when you're multiplying and dividing, the index of the terms have to be the same. So this is a square root, this is a square root. Any square root, the index is a 2. So if I look at this, the square root of 36, that's the index is a 2. I don't write it because it's understood if there's nothing there, it stays a 2. And that means how many pairs can you pull out of the same thing? This is 6. If it's the cube root, index of 3, you pull groups of 3. Index of 4 has groups of 4. So then I look at these examples, 2 square roots of 5 plus 8 square roots of 5. They're both the same. It's like saying 2x plus 8x. So that means I have 10 of the same thing. 10 square roots of 5. This index has a 3, this index has a 4. I can't do anything, so this is already in simplest form. The next one, the radicand has a 2x, this has an 18x. I cannot subtract the rad or can't do anything with these, but I can reduce the 18. So I have an 8 square root of 2x minus, this would be the square root of 9, square root of 2x. Square root of 9 is 3. So I have 8 square root of 2x minus 3 square root of 2x. So now I can go ahead and combine like terms. 8 minus 3 is 5. And the radicand is the same. So it's 5 square root of 2x. The last example I have a 28x squared. So hopefully now you're starting to get better at looking to reduce fraction or radicals. So I've got the square root of 28, square root of x squared, square root of 63. 28 reduces the square root of 4 times the square root of 7. And we know this is the square root of x squared. 63 is going to be 9 multiplied by 7. I always put my perfect square first. It helps me keep track of things. So the square root of 4 is 2. The square root of x squared is x. And I'm not going to worry about my absolute value bars at this point. And the square root of 7 did not reduce. This 5x is going to be multiplied by the square root of 9. So the square root of 9 is 3. So I'm going to have 5x multiplied by 3 square roots of 7. 2x square root of 7 plus 15x square root of 7. Combine like terms, I get 17x square root of 7. And I'm not going to worry about the absolute value bars.